Okay, on this third edition of metrology.net test package training, we're going to cover how to use the test package store, and we'll also cover how to build the test packages using an Excel file. Also added a test package store. And inside of this test package store, you can come in and you can grab free procedures. So if you needed this 34405 and you wanted to add it, it's free. You just click the plus button and it copies it over. The other thing you can do is you'll see a green shopping cart. This will allow you to process a credit card and get the procedure right then and there. So anytime, day or night. And right now, this only works on the AWS system. The self-hosted people, we've got to work on some code to get these to synchronize and pull down. So, but this one, it'll also show you that it's out of date, right? So you can see that the current version is the version that is the customer has is a 230719. The current version is a 241204. So that will let you see, hey, you need to go get an update. So the other thing that we've done now, we've shown you guys in all the structured training that we've put together, how to use the user interface to build out your test packages. But we all know that for advanced programmers, that's actually a lot of work. It takes a lot of time to do points and clicks to get things figured out. It's easy with the user interface because it becomes more intuitive. You need to be less knowledgeable. But as you become more and more knowledgeable, you want a tool that works a little bit better. So that's why we've created, and if anybody doesn't have this, please let me know and I will send it out to you. That's why we have this metrology.net test package in Excel formatter. But this is an updated version of the editor that will that is more functional to how we do things currently. So, and I'll just jump through some of the key things. I'm talking about the key definitions. Over here, we've got GUIDs, generally unique identifiers. We talk about parameters, station agents. So I try to get all of the key words that I'm talking about in the document. I tried to get those up here. If you spot any things that you think should be a key definition, let me know. We can do an update to the document. So then we start coming in here to the overall sheet layout and how to use things. We're working on doing an update to the uploader tool, but we haven't got that done. Once we do that, sheet 1 will probably be changed to test package header or something. So, but these are some of the rules that you have to have now. Is the first sheet has to be named sheet 1 or the system can't find it. And then you've got to contain things inside of here, unique IDs, which are GUIDs. For those of you who don't know what a GUID is, it's a genuinely unique ID that is 24 to the 36th power. No, 34th power. So it's 24 to the 34th power. It is a very, very big number. So that allows us to create unique IDs inside of a spreadsheet that will most likely not collide with the GUID inside of the database. So, and then this is how we're going, oh, here we go, I've got it. So a GUID is 5.3 e to the 36th is how big that number gets. So, and one of the rules that you're going to have is do not copy your GUIDs, right? They're 36 characters. Do not copy them. You should make it a habit that anytime you copy something that has a GUID in it, the very next thing you do is go in and replace them with this keyword called GUID. So you're going to go in there and replace those. So I'll kick this over as an example with my sheet, and I'll be jumping back and forth. So if I was going to create a new tab in here, right, and I was going to copy this data from tab A to tab B, the very next thing I should do is go through all of these GUIDs and replace them with this genuinely unique identifier. And what this text does is we have a tool that will go generate random keys for this. So, and these keys have to be random and generated. A lot of people have got some pseudo GUID creation tools that will create duplicate GUIDs. We have a tool that is very unlikely to create multiple GUIDs. But that's the thing that you want to do. Anytime you copy and paste one of these GUIDs, and we started highlighting them in blue, you want to replace that with the name GUID so you're not trying to write the transaction to the database twice. So that's some of the rules that we've got to keep up with metrology.net. And then you can see here that at the end of this, I'm going to talk about the upload tool and how to use the upload tool. There's a lot of features in the upload tool, and the upload tool is open source. So you guys can come in if you want to add a feature to it. You can come back in, branch it, add the feature. So sheet one, the rules for the sheet one. Sheet one is going to be the test package sheet. So, and we're going to start up here with a test package ID and an asset type ID. And then these are freeform text, name, description. And we like to keep the version number in year, month, day format. So now I can see when was the last time we've done an update. That makes it very easy for me if we've made some kind of a structural change and we know the date that we did that. Say I made a structural change December 31st, 2023. I could go in and look here very quickly and see, hey, this test package doesn't have that structural change to it. So maybe that's the first thing that I need to go in and do, is go in and kick in that structural change. So here I'll jump back to this. This is our 34450 sheet one. And you can see up here, I used to have GUID in there, but now I've used the upload tool to generate me actual GUID, so actual random IDs. And then you can see there's my date format, and this is library. Inside of these spreadsheets, they're always going to be set to true. So that's one of the things you just set it in there and leave it. And we do have templates that we send out that will help you with creating these. And I'm working on some tools to further streamline creating these packages. So, and then this will talk about what needs to go into each one of the fields, right? So here's one that's actually filled out. So then we'll go down to the, this is a different example of one. So you can see that these GUIDs, we don't want to repeat those, but we want to keep the format kind of the same. So now the next part of this is going to be the test package parameters. So these are parameters that metrology.net puts at that test package level. They are, when you're creating your own test packages, you can put them in there any way that you want to. For this one, we put the document that we use to create this procedure. We put in the list price, which is $0, and we put in the owner who created this CalLab Solutions. I can add additional notes and things that I may want to put in here. You can add as much extra metadata as you want to put in here. And then again, we want to put in GUID, and the system is going to replace those GUIDs. And you're going to hear me talk about GUIDs and replacing those a lot. I kind of want to get it in people's heads that you have to manually replace these with GUIDs. Otherwise, you start getting a lot of duplicates in your database because it's writing data again and again and again. The next section of this is we're going to start talking about make model information. So in here, we've got product line. We talked about how I use product lines different. We've got model group name. We've got models, descriptions, and then a whole bunch of options. So when we look in here, the product line is an adjuvant. A future update, we're going to want it to, when you put in key site over here, that it'll be able to make a key site version of each one of these as well. So then we've got Agilent 34450 as our series. Row 13 and row 12, those two are tied together. So if we ever do an update to the style of this, we'll get those two elements closer together. Then in this model group, there's only one model number, model description. So, and you can see here that we've got 1/2, right? 1 divided by 2. You can use the 1/2 in the description, but what'll happen is when it pushes it up to the web, it's going to list that as a question mark, question mark, question mark, because the HTML doesn't know how to automatically convert that. Then the next part of this is we're going to start talking about options. And then here you can see that this one only has one option. It's a 1-year cal and it's available on the 34450. So you could add another option in here, which might be a 90-day cal, and we could put that there. But I don't think they ever put 90-day cal specs out on this. I'll pull up another one that's a little more complicated. This is one that's in the free package. And we can see here this guy has no options, but it's got 2 model groups it's covered. Another one that's up here is this MDO 2000. This one's a lot more complex. Well, this one's got a lot more models, but again, no options. Let me find one that's got options inside of it. The MDO 3. This is one that's paid for, but you can see how it's handling the options in here. So inside of here, there's 2 versions of it, the MDO 32, MDO 34. And then the options are 100 meg, 200 meg, 500 meg. And then you can see down here that we can put all of these options in. If a model can't have an option, you just don't put the X down here, and it doesn't build out that matrix. So, and then to answer a question that came up in the chat, the reason that the past database with multiple options was because we no longer look at this value when we're writing. We've actually moved to just using the name is how we synchronize between the UU or between the units that have the option installed and the model. We use the name. We no longer use these unique IDs because it had a problem putting duplicates of these names in the database. So, but this right here, go ahead and still fill it out, even though we're not using it. Keep those GUIDs in there. And then here I've got some options in here. I'm pulling them up so you can see this 8590, that this option 01 is available in these models, these first 2 models, but it's not available in a 93. But you can't have an option 1 in a 91C. So that's how you can go in and configure these options. So now the user can't make a model, assign the options to a unit under test where the options are not available or not configurable inside of there. So, and then here's another one with the 34410s. And then here you can see that we created this option of cal option. And we called it a 24 cal, 90-day cal, 1-year cal. So that package has those different calibration specs built into the package. So next we're going to move into the test group. And the test group for a test package is a 1 to n. So you can build as many test groups as required to the data points that's going to go into this calibration. And every one of the test groups is going to have this header section. So you can see that we've got a test group ID that is going to be a GUID. We got the name, the description, the is live. We've got to set that to 2. The sequence, This is going to be the sequence that that test group appears in the order. And then we can put in a taxonomy. We can put in a parameter names, a GUID and a value, and we can put multiple parameters in here that apply to that test group. We can put in the file name of a Visa script, put in the Visa script and the GUID. So you can get a list of the metrology taxonomies from here. And then we're just going to come in and start talking about these things that we're going to put into here. So one of the keywords that we have is UUT input, UUT output. That helps the UI give the connection message to the user. Where is he going to connect it? And then we also have some keywords in here. And this is where you can get the list of all the keywords that's going to help determine if that test group or that test point gets tested on that UUT that's there. So we have an applies to model, applies to option, applies to option list. The list has to be comma separated. The applies to serial number above, applies to serial number below. That's going to look at the first part of the serial number and make the determination. So if you have like a B00065, it's going to throw away the B and it's going to look at the first set of numbers that's in that serial number. And then we've got remove if model and remove if option. So sometimes it's easier to negate something than it is to do the applies to and give it a list. You could just say, if this option is there, don't do this data point. So it will remove that test group or that data point. So here we can look at a simple one, our 34450. Look at our AC voltage, which is what we were looking at. And you can see up here, I've got my GUID. I've got my step number. Now, one of the neat things to do with the sequence number, I found this out, or somebody showed me this. You can do an equal sheet. And then that will automatically set that sheet in its order. Okay, so now if I move that sheet around, it automatically keeps the order that we have in here. So you see there it changed to 6, changed to 5. So that's one of the things that that's a nice little handy thing to makes us easier to do stuff with. So is that sheet minus. You can freeform in your taxonomy, and then you can put in your data points as well as your Visa script. So, and we'll cover more about the Visa script a little bit later. So I'm going to jump back into here and we can start looking at some of these. Oh, I don't have any examples. So let me put up a few examples of these. So we'll go back into one of the examples I had, this guy. And we'll jump over here to DC amps, right? So our DC current test. This one applies the model. So this DC amps test is only done on this model. Same thing with AC amps tests. And then I'll pull up my O-scope again, because this has some good ones back here when we look at frequency. So we'll look at, I'm sorry, not frequency, bandwidth. So when we look at the bandwidth data points on here, oh, this one isn't that big. So we've got a 70 megahertz, 100 megahertz, a 200 megahertz bandwidth. And when we look all the way back here, you can see how those applies to, right? It's just going to list the models that we do this on. So we can put them there, or we could build a test group and put it up here in the test group when we want to handle those applies to and work out the logic of that. All right, moving right along to our test points. So inside of our test points, like we had in the main screen, we have this required data. So we can do a test point description, a test point ID. That's going to be that GUID again that we want to replace. We've got our sequence and we've got our step number. Then we can put in our upper or lower limit, nominal value, upper limit, format, modifier, and then what kind of test type we want and the unit of measure. So a lot to take in, but that's the core of what we're going to do with any one of our data points. So, and I'll pull this one up and show you some of the things that we have in there. So this can either be text or there'll be some of the newer ones that have those as drop downs. The template that we give you has these as drop downs, and you can just select it as a drop down as you go in and get it. So it makes it less likely that you're going to make a mistake. And all the drop downs are kind of come out of this in tab. And this is where we're putting in the drop downs for that. So this gives you all the things that you can put in there with your drop downs. So here you can see that we put in a test description. And then we've got these step numbers. I want to jump to this guy. Because this guy, when you open the manual, there's a table in there that's called 1.3. And this is the 0.2 step out of that manual. So the sequence, we want to put the sequence in as the order that we're going to report the data. And then we want to put the step number in if it's a reference that we directly reference inside of that manual. Or we can just call it, the same as the sequence number. The other thing, since I learned this little sheet trick up here, there's another trick here, which is called row minus 13. So now I can use that function. So now if I need to rearrange my data points, I don't have to come back in and rearrange my sequence numbers. It happens automatically. Then my format, right? This is going to give me the format that I want my data in, my nominal value, and I can start using calculations to figure out what the values are. So here, the manual told me that I'm going to do plus or minus 1.22. So I just put it in here as a math function. And then I told this to be the opposite of that from my nominal. So that allowed me to do calculations to get to my upper and lower limits a little bit quicker than I can get to it manually entering the data and making sure they're symmetrical. So typically you'll see me edit one side and then the other side will make it symmetrical. We've added into the new template, though we haven't put drop downs, we've actually added the units of measure. So, see, there's a units of measure column in here. It's just not populated. The template that we give you for editing these actually has all the metrology.net known units of measure in it. And it's got a drop down that will help that. So, and then here's one that's out of a 34401. You can see all of the range points that were in there and unit of measure and whatnot. The next part of this is going to be the test point parameters. So, and you can see I got a lot of different ways to do it. But you want to have the parameters be frequency followed by, or the name of the parameter followed by the ID. So instead of putting them on top of each other like we do in the header section, we put them next to each other and let them go out. So we'll jump out to this key site one that we were looking at. And you can see here it's got the current and the range and the frequency. So it's got that data put out there so that you can grab those. When we look at AC volts, we've got our voltage, our range, frequency, and then here we've got an applies to model that I should delete because we're not using it. If there's no data in here, it won't upload it, and then it will only upload it where it sees the data. So another thing that we have added, so I have these different ways of formatting the data, and a lot of it is just to make it look pretty on the screen. So here we've got 500 E minus 3 as opposed to 5 E minus 5. To me, reading scientific notation is a little bit rough. So we have these formatters in here that you can come in and use. So this is an example where this should be 1K hertz instead of 1000. So I can come in here and do my format cells. And then here we've added in some custom formatters. So this right here is going to move it to scientific or to engineering notation. So it will put it in as a 1E3, but that engineering notation doesn't cover enough resolution. So inside of the templates, we've added this format. And this format is going to be number. We're always going to put at least 2 digits, and then we're going to put in up to 9 digits of resolution. So that just helps us when we need to format something where we need more precision. That format is now in the templates that we send out to everybody. And then there's another one in here that does a really good job of formatting the numbers until you get to numbers that are E-3. That's where it starts having a problem, that it can't format a negative E-3. So a negative 1 E-3, it doesn't know how to format that. So that's where you've got to go back in and either grab this one or grab this engineering notation to get it to write out the way you want it to. But we've added some of these in here so that you can see the different formats. So this one will format it to a general number or an E- number. So that's handy, so you don't get E- zeros, which is what you would get if you put 10 in here. See, you're going to get an E plus 0, whereas this formatter doesn't do this. And then this one will handle negative numbers, negative components. But I have not found a way to do negative 100 E-3. So there's not a formatter that I can find in Excel that does that. So, and then again, you're going to look at the metrology taxonomy to find out what all units, what all things you need to put in here with your parameters. And then I've started using UUT dot. So if I want to talk specifically about the UUT range, all of my newer packages, they'll start talking UUT dot range. So I'm not getting a range parameter configured with the standard. I kind of know that that's a UUT specific setting, where these are general settings. So today I would call this one, instead of center frequency, I would call it UUT dot center frequency. So things evolve as we run through these. So, and then just a kind of a note in here on measurement uncertainties. I don't think a test package should have the measurement uncertainty coded in the test package, because the test package is about the unit under test, the thing that we're testing. So if you code in a measurement uncertainty for the standard out of the manual that they should be using, then technicians get lazy and they don't replace that uncertainty when they use a different standard. So now you're either over-reporting or under-reporting your measurement uncertainties when technicians run the calibrations.
Way to make a resource communicate to the standard?
No.
Like, say, for instance, to turn the low I option on a 8508.
So there is a way to do that. And when you sit back and you look at the metrology behind that, the low I option is a current limit that the device doesn't want you to put more than a certain amount of current in it. When you go back and look at the updated taxonomy for resistance, you'll see that we now have a current setting. And by adjusting that current setting, the driver will handle the low I setting. Because here's the real world problem of that. When you're calibrating a Keysight oscilloscope, right, and you want to measure the 1 meg input, they tell you in the manual to use the 10 meg range of the 3458. So now the unit under test has to have knowledge of the standard. So instead of telling the 3458 to go to the 10 meg range, what we've added into the 3458 drivers is the output current at each one of those ranges And if it sees a range or if it sees a current specification, then it auto ranges up until it meets that current specification. So does that answer your question, Scott?
Yeah, somewhat.
Yeah, it's to me it's just a more metrological way of handling that
Right.
because, now when you go to test it with the 3458 it has a problem, how do you handle that problem in the 3458?
Yeah.
Right?
Another issue Another issue that I run into is measuring AC voltage and AC current using the 8508, is being able to set the filter to 10 hertz and below, and also being able to set the DC coupled. And I haven't really figured out how to get it to do that other than modifying the source code for the driver.
Yeah, yeah. Well, what we need to do, and I believe the 8508 actually it might I believe the 8508 has an update. We'll have to go in and check that where below a certain frequency, I automatically turn the filter on.
Right,
But I know I did that in one of those two drivers when I was working with the guys at EMI, the UAE's metrology lab, because we ran into that being a problem. We couldn't get the measurement we wanted, and it was because I wasn't setting the filter.
right.
So, and then, those of you guys out there who kind of new to working with me, the more I can get these and get these into the drivers and make the drivers more intelligent, the better it is. So, all right, well, I'm going to continue on. We're almost done with this. Yep. So here with your question, so you see these optional parameters, you can give it the recommended volts and you can give it the recommended amps. So that's how you get it to change to that low I. So it'll change to a low I or it will range up by setting that amps requirement. And then it was mostly for me looking at the fixed resistors. So sometimes giving different current into different fixed resistors, they behave different. So that's why it got put in here this way as a not to exceed. It just comes into recommended current. And I know the 3458 does this. I just can't remember if it was the 8588 or 8508 or both that I've coded this into with the low I. So that covers the test package store, and it's always a wise idea to check the test package store before you start building a new test package on your own. And then also how to do it inside of the Excel files. There'll be more to cover with that as we have to go over how to use the upload tool. But I like to make sure that we can check people's Excel files and get rid of the nitnoid mistakes before we go into learning how to use the upload tool.